It's a great way of looking. I've never thought about that before. That's exactly what you're looking at. You're measuring the contrast. It's perfect. All right. Let's finish this bad boy off. Do one more. So you guys understand what a matched pair test looks like. You know what this one looks like, obviously. We're going to do the next one as well. Okay, so we are down to the part of the template about which distribution. We've already answered that, yes. It's going to be a t distribution. We're going to use a t-test, for sure, for sure. Now we need the test statistic and the p-value. Test statistic and the p-value. So what I'm going to do is I'm going to turn these graphs off, because the TI is going to draw the t-curve on this axis, and it's going to be confusing if we have the box plot and the histogram with the bell curve. Because these are the sample data, the bell curve is the sampling distribution, which is a different distribution. So I'm going to turn these bad boys off. Go to Stat Tests, grab a t-test. Yes. And all you've got to do is make sure it's set up right. This is from yesterday. This isn't where our stuff is, though. Nah. We've got data. Well, what's our null mu?
L3.
Yep. Well, that's our data is L3, but our null mu is actually 0. We're testing against 0, yeah? We're testing against 0. Good. Our data, as Elizabeth, I think Elizabeth said, L3, yes? Frequency?
1.
Just 1. We're testing greater than, so I like where that is. And you guys like draw? I do too. Here it comes. Now, actually, the commercial out of the show on the commercial, that's actually correct. That still does sync up with, all right! That's where the area should be. If there's area, it should be to the right, because it's our right-tailed test. Good. Tracy, what's on your mind right now? Tell us what's on your mind. I love that look.
I'm trying to read it.
Oh, you're trying to read it? Oh, you're not getting the same thing? Hang on. Just set the mood
It
lighting.
could be something that, my data.
Well, it's also because it's 1984 technology and they didn't give us backlit screens, which is lovely. Oh, I can also make the lights better. Hang on. How's that? A little better? Here we go. We got a test statistic, 1.09-ish. T equals, when it says with the correct variable, just write the variable t. T equals 1.09. 1.09 what?
Standard deviation.
Good! Yes! It's a standard error, standard deviation of the sampling distribution. Good. P-value, 14.42. You guys get the same thing I am?
Yep.
7 and 8. 14.42. Okay. Conclusion.
It is not significant.
Everybody hear that? We got ourselves a negative test result, didn't we? We got ourselves a negative test result, which means it doesn't look like the commercials are all that much louder. Now, of course, I want to, again, revisit Chris and Anna's awesome questions. Are they louder? Yes. Are they significantly louder? No. According to this test, Anna, yes ma'am. According to this test, yes. And also according to what? 5%, right? 5%. If you were testing at 80% confidence, this would be significant, wouldn't it? This would be because it's below 20%. Right. But we're not. Let's just always test at 5 in class. I do that for 2 reasons. Number 1, for simplicity. Number 2, for practice. So we're doing the same procedure. Once the procedure's automated, you guys can switch the percentage anytime you need to. And thirdly, I guess there's a third reason too. You see it all the time in the journals, for better or for worse. So, we definitely do have evidence that does not appear the commercials are significantly louder. And Chris, we don't have to worry about whether we think it is not. It doesn't look like the commercials are significantly louder than the show. Could we be wrong?
Yes.
Of course we could. Jake, you were concerned about a type 2 error, weren't you? I think you were the one, you said, I don't want to make a type 2. I don't mind making a type 1, but I don't want to make a type 2. Remember that? Remember what? So, do you see the discussion I was just having with Anna nods to that. Suppose we do not want to make a type 2 error. You see how lowering confidence would help with that? If you lower confidence, say to 80%, this would then be a small p-value, wouldn't it? Think about that. If you lower, now this is a little bit weird, Casey, I know. If you lowered confidence to 80%, we're no longer testing at 5%, we're testing at 20%. That's under 20%, correct? So if we were testing at 20% significance, which I'm never going to ask you to do in this class, we would then say it appears the commercials are louder. which means we would avoid a false negative, right? A negative would be like, the commercials are fine, when they're actually not. If you lower your confidence low enough, it's going to trigger positive test results more frequently, which means it's harder to miss them. Does that make sense? If that doesn't make sense, don't worry. It's your fourth project is all about that. Just so you know. I mean, that's not the simplest idea to grasp, but you can see the rectification of it right now with your guys' concerns. Is that okay? Now a type, Ben, go.
Just to review.
Go, please.
Because
I love
the
this.
p-value is
Bigger than
14%.
Yes,
bigger than
5. Yeah, we're testing at 5 all the time in here.
and that would be a type 2 error.
Potential type 2 error, right? The only reason I did a little sidebar conversation was because what if you definitely want to avoid a type 2? Well, then test at a lower confidence. You'll get fewer type 2s that way, which means you're less likely to make a mistake with a type. If you're getting fewer of them, you're going to make less mistakes because you're not having as many. Now, Elizabeth, this is not going to help you at all because the data is not significant enough to avoid a type 1, so we don't have to worry about that. We're dancing a cool dance here. You don't like it so much, it's okay. It's 8:15 in the morning. I can appreciate that. Now, what's interesting about this was, I was like, wow, how is it then that everybody seems to, now you got to remember, this is one set of data from one school in Texas. I have not been able to replicate this data myself, mostly because I have no time to actually sit down with the machines and test the commercials. Now, since this study's been done, internet TV has changed the game in many, many ways, where you've got these customizable commercial experiences. So, I mean, what I have to do is slap the digital antenna up and start testing commercials myself, which one of these days I'll find the time to do when Max is in college. Come back and visit me in 20 years. But what is interesting about this was I did a little bit of digging once I got this result with my class the first time. I said, this is kind of interesting.